Okay, so we're going to start with angles of elevation and depression today. To start us off, we're going to look at the definitions of what an angle of elevation or depression is. So an angle of the angle formed from the horizontal at your eye level to the raised or elevated line of sight is called an angle of elevation. So anytime like you're looking up at a plane or something in the sky or something in a tree, that would be an angle of elevation where you're looking up. The angle of depression describes an angle from a horizontal at the top of an object to the line of sight below. So say if you were in that airplane looking down at something on the ground, or if you were up in a really tall building looking at something on the ground, that would be an angle of depression. So we're going to take a look at these problems down here. 1, 2, 3, 4. We're going to look at whether or not those angles are angles of elevation or depression. So when I look here at angle 1, this is up from the bird's point of view, right? From their line of sight, looking down, that would be an angle of depression because the birds are up and they're looking down at the boat below. So that would be depression. I'm just going to put a D there. Okay. Angle 2, let's say that somebody's on the boat here and this is their angle for their eyesight looking up at the birds. That would be an angle of elevation because they are looking up. Let's see, angle 3. Angle 3, again, we're starting at the boat up here and we're looking down below the surface of the water at a submarine. So anytime we're looking down, that's going to be angle of depression. And then angle 4, if we're looking from the submarine back up to that same boat, it's going to be an angle of elevation. Okay, so let's look at a couple of examples. We'll start off with example 9 down here. So from our guy's perspective down here, we have our man drawn in. He's looking up at a kite, right? This is going to be an angle of elevation. The angle of elevation from his line of sight up to that kite is 40 degrees, okay? So we can go ahead and label this as angle of elevation if we want to, just so we know what we're looking at. Angle of elevation. And then we're supposed to solve or find the value of x. So this is still a right triangle, right? There's a right triangle formed from the kite's position to the man looking at the kite. So we have this right triangle, we have an angle, and we have one side. So we know we're going to be using our trig functions because it's not a special right triangle. And again, we only have the one angle on the side. So I'm going to use our special SOHCAHTOA. I'll even write that right here. SOHCAHTOA. So we have that. So if this is my man and I have my two sides, one that's next to me and one that's the hypotenuse. So again, from across from that right angle, that's my hypotenuse. Right next to me, we call that adjacent. So that means I'm going to use my cosine for my trig function. So I'll start with my cosine of the angle I'm standing on, which is 40 degrees, is equal to the adjacent over hypotenuse, so that's x over 125. So what we're going to do now, to get rid of that 125 in the denominator, we'll multiply by 125 on both sides. Those cancel out. And then I'll get my calculator here. Remember, it's got to be in degree mode for it to work. So we'll do 125 times the cosine of 40. And we get about 95.8 if we're rounding to the nearest tenth. So x is approximately 95.8 feet, right? So he's about 98 or 95.8 feet from being directly underneath that kite. So there's our answer. All right, let's look at number 10. So number 10, there's a height of a building here, and we are down here on the ground looking up at the top of that building. So this is going to be one of those angle of elevations again. Same kind of deal. Angle of elevation. So when we have that angle of elevation, again, that building here forms a right triangle with the ground and our line of sight. So now let's go ahead and label our sides, because again, we do have a special right triangle, so we could use that shortcut as well, or we could do sine, cosine, tangent. That will work every time. So let's go ahead and label our sides here. I have a side that is opposite from me, and I have a side that is adjacent to me. So I'm going to use tangent. So I would say the tangent of the angle I'm standing on at 30 degrees is equal to my opposite side, which is x, over 300. And then to get rid of that 300 in the denominator, we're going to go ahead and multiply by 300 on both sides. Remember, anything we do to one side, we have to do the other. We use inverse operations the whole way through. Okay, so I'm going to get my calculator again and do tangent. Oh, actually, I'm going to do 300 times tangent of 30. I'm going to put 2 parentheses to make sure I close both the 30 and then the tangent that's already in parentheses. So I get about 173.2 feet. Let me write my units in there. Whoop, I ran out of room here. I'm going to put 173.2 feet is what approximately x is equal to. So when you're looking at these, sometimes we get big numbers and it makes us nervous, but if you look at what we're looking at here, this is a really tall building, right? So if we're trying to figure out how tall the building is, it does make sense that it'd be 173 feet. If we're talking about what a tree is, maybe not, but for a building, that makes sense. It's always a good idea to kind of check and see if what you're doing or what answers you get make some sense.